The syntax here used to feel like a total mystery. But my goal is to teach you Python like nobody else does. We're diving deep into the core mechanics. That is exactly what makes you an expert. You won't just follow the documentation. You will instinctively know why it works. Let's see it in action. Let's start with a very basic loop. We have a dictionary. Think of it as a set of key value pairs. We have a laptop in stock with a quantity of 12. Then we have a mouse with a quantity of 40. Now, the basic loop, the for loop. We iterate through this, printing each product name. Then, from the dictionary, using the product variable, we look up the current quantity value. But instead of manual lookups, there's a better way. You can use a much cleaner, shorter syntax. This method gives you the product and volume together, allowing you to print them instantly. You don't need the old way. By using the items method, you avoid that clunky lookup. This used to feel like magic to me. I didn't quite grasp it. So what's the secret? Let's break it down. I've added one extra step to clarify this. Same code, same dictionary. But now I'll print this stock view variable. Wait, let me show you the original results first. Here, we see the laptop and the mouse listed. And if I print the top one, it's the same result. Everything is working. Now, let's look at what the items method actually does. This is where the real insight happens. I've named this stock view. Let's see what it returns. Look at that. It returns pairs for the items, a tuple for the laptop, and one for the mouse. It looks just like a list. So when you run this, you can imagine the dictionary being represented like this. It's no longer just a map. It behaves like a list. Well, almost a list. There's more happening behind the scenes. But now, instead of cryptic code, the logic becomes crystal clear. Now you can truly master how this works. Stock view holds the result of the items method. And we know exactly what that is. It looks like this collection here, like a list of pairs. Technically, it's a Dict items object, a very special type, but it functions like a list. When you loop through it, watch the syntax. It targets the stock view. Think of it as iterating through a list of tuples. Inside that view, everything is neatly separated by commas. The product and volume are pulled right from there. Each pair is unpacked as we go, and that is the magic. I spent years wondering, but now it's finally clear. Check out the final output. There are many ways to write a loop. The first way is simple, but if you want to understand the engine, use this intermediate step of storing the result in its own variable. Print it out and see for yourself. The confusion is gone, replaced by clarity. This is the best syntax to use. The old way is traditional, but this shows you exactly what happens underneath. That intermediate step is optional, but it's your key to mastery. Let's dive into nested dictionaries. They are incredibly powerful for storing complex, multi-layered data. This is a standard setup. Let's look at this employee list. We have employee 1 and employee 2. For instance, Samantha serves as our data analyst. And here is Aisha, our talented back-end engineer. We're starting with 2, but this structure can scale to thousands. We need to store the name and role for each person. Names and roles, simple and clean, that is our data structure. Now, to print these values, say you need employee 1's specific role. Here's how you access it. We use a technique called dictionary chaining. Start with your dictionary variable name. Then, we index into the specific item we want. First, we target employee 1. Then, we grab the role. The first key pulls this entire block of employee data. The second key isolates the role from that block. Run the code, and there it is, back-end engineer. This process extracts values with precision. It finds the main entry first, then chains to the sub-item to get the result. It's a perfect extraction. To loop through a nested dictionary like this, we define variables for the employee and their details. We use the .items method to return our data pairs. This creates a collection that we can easily unpack. We'll store the employee ID separately from their details. The ID is our key, and the details are the value. Everything is organized and accessible. Watch the output. I've used a comma to separate these. Python automatically adds a clean space for us right here. See that? emp1 is our very first dictionary key. That's the key, and its value is this entire inner block. Simple, right? Key on the left, value on the right. It's all about keys and values. Now, for the exciting part, the nesting. The value is actually another dictionary. So how do we reach the data inside? We simply create a second loop. Add another for loop to dig one level deeper. This time, we'll label the keys as field names, and the values will be the actual employee information. There's Aisha's data, and now for the next one, we move right along to Samantha. By calling dot items on the details, we unpack that inner data. This gives us a clean pair to work with in every pass. When you run it, the output is beautiful. For employee 1, our inner loop finds the name field. It links the name key to the actual person. Then it grabs the role key for the back-end engineer. It's perfectly segmented. Employee 2 follows the exact same pattern. Name, Samantha, role, data analyst. Those are our field values. Just think key and value. I've used field name and value for clarity. But you can name them anything. Call it chicken if you like, or hamburger. The name is entirely up to you. But for professional code, we treat these like database fields. A field name and its corresponding data. In the world of dictionaries, it's always about that key and value relationship, over and over again. Remember, a value isn't restricted to text. It can be a whole new data structure. Like right here, a nested dictionary. One dictionary living inside another. Powerful stuff. Don't forget to like and subscribe. Your support helps me bring Python mastery to billions of people across the globe. See you next time. Let's be honest, merging dictionaries can feel tricky. But today, we're changing that. Let's break it down and make it simple. I'm on a mission to teach Python to 1 billion people, and I want you to master the art of dictionary merging. Let's look at a real-world scenario. We love scenarios. Imagine a user with specific app settings. This is a standard task for any application. It's incredibly common. Apps rely on settings and environment variables, and often you need to override them. There is almost always a default setting. Every program starts with a baseline, but when a user makes a change, they create their own preferences. So which one should the program use? Great question. Here, we have our defaults. The theme is light and notifications are set to true. Remember, dictionaries use keys and values. That is our key and that is the value. It's all about key-value pairs. Now, the user decides to change just one thing from the default. Just one single preference. They want the theme to be dark instead of light. They're done with the light mode. Now, your code must decide how to apply these. Should it use the default or the user's choice? If the user settings are empty, we stick with the defaults. This is where this handy merging technique comes in. We merge them together. Yes, you heard that right. Merge. We combine the two using the pipe operator. When we print this, something interesting happens. The final theme is now set to dark. Notifications remain true. Wait, what happened to the light theme? When Python merges dictionaries with the pipe symbol, it prioritizes the values on the right-hand side. It keeps the user's setting for that specific key. If a key exists in the right dictionary, it wins. Every time. I can prove this by changing the name to theme 1. Now it's a completely different key. Now you see both theme and theme 1 in the result. But if the keys match, the left one gets overwritten. The right side always takes priority. It successfully overrides the default value. Notice how the merge kept the keys that were originally in the defaults. Notifications were left untouched. If the user hasn't applied any settings at all, and we have an empty dictionary, look what happens. The original theme and notifications are preserved. The empty dictionary is simply ignored. This is perfect for when an app first launches. There are no custom settings yet, but once they are added, dark mode takes over instantly. The user has total control. This is exactly how modern tools like VS Code handle settings. Now you know how dictionary merging works, and how to override defaults like a pro. Remember, the right side always wins. It's a powerful, elegant trick. I hope you enjoyed this. Come back tomorrow for more. Let's dive into some incredibly powerful dictionary methods. These tools will completely transform how you handle data. Take a look at this dictionary. A dictionary is defined by these distinctive curly braces. The data is organized into keys and values. The key appears before the colon, and the value follows right after. We separate these key-value pairs using a simple comma. Now, here's a second dictionary. It follows the same structure. When we merge them using the vertical pipe operator, the dictionary on the right always takes priority. So if both dictionaries share the same key, like theme here, the version on the right wins. The right side value takes precedence. Watch what happens when we merge the default dictionary with these specific user settings. The theme is light in the defaults, but dark in the user settings. The user's dark theme choice overrides the default. That's the final result. This is exactly how Python handles conflicts during a merge. Running the code, you see the theme is dark and notifications are true. The items are now perfectly combined. Next, you can check if a specific key actually exists inside a dictionary. This is one of the most useful techniques you'll ever use. We use the in operator for this. We are scanning the variable final settings to see if the theme key is present. Executing this returns the value true. But watch this. If I comment these lines out, the theme will no longer exist. Let's run it again. As you can see, theme is missing from the output. Now, the check returns false because the key is gone. Using this method, you can also search for specific values. It isn't just limited to checking keys. If you add the values method, Python will check for a specific entry like the string dark. It looks through the values assigned to each key to find a match. If you search for something else like dark1, you will get a false response immediately. Another essential method is pop. It removes an item and captures its value inside a variable for you to use. I've declared a variable to store it here. After popping the theme key, the dictionary is updated and now only contains the notification settings. The extracted value was dark, which is now held in our variable. The pop method returns the exact item that was removed. Next, let's explore the keys method. This allows you to print every available key. In our original dictionary, we had theme and notifications as our primary identifiers. Those are the keys, and this is how you display them. Finally, we can call the values method. This gives us dark and true. These reflect our current settings. Remember, the theme changed to dark after the merge, and our notification values stayed true. That's why you see both results right here at the bottom. Master these methods to level up your dictionary skills. Happy coding! Welcome back. Today we are mastering one of Python's most essential tools, the powerful dictionary. This is what it looks like in action. Wrapped in curly braces, dictionaries organize data using key-value pairs. The key sits on the left, followed by a colon and its assigned value. Think of it as a label and its content. Label, value, label, value. Each of these unique pairs is neatly separated from the next one by a simple comma as shown here. In this example, brand is our label and Ford is the value. But look closely at these repeats. How does Python handle duplicates? What do you think happens when year and model appear more than once? Model is listed twice here. First as Mustang, then as Ford. Then we have the year set to 1964, then 2020, and finally 2021. How will Python react? Let's print this dictionary to reveal the truth. Notice the results. Brand is Ford, and model is also Ford. What happened to the rest? The original model was overwritten, and the year is now 2021. The older entries simply vanished. Behind the scenes, Python is reassigning those keys. We started with Mustang, but as soon as Python found another model key, it replaced the old entry with the new one. Duplicate keys are not allowed. The year 2021 wins the race. The earlier years were overwritten by the very last entry we provided. In Python, the last one wins. Because this was the final entry, it takes the prize. The last model wins the same way, wiping out any previous values. If you need to store multiple years, don't repeat the keys. Instead, assign them all to a single key like this. We'll group 1964, 2020, and 2021 into one list and clean up the rest. I'll also remove that duplicate model entry. Now, when we run the code, year holds all three values. Perfect and organized. That is how you store multiple values correctly in a dictionary, ensuring your data is never overwritten again. Let's explore a vital concept, Python dictionary views. Do you know how they work? I'm on a mission to teach Python to 1 billion people, including you. Today, we are diving deep into the dynamic world of dictionary views. Observe this dictionary. We have 3 trucks as keys. Truck 1 is delivering. Truck 2 is idle, and Truck 3 is in maintenance. Truck 3 is struggling, while Truck 2 is taking it easy. Our goal is to extract and print the keys, essentially the names of trucks 1, 2, and 3. Next, we want to capture their current values. We call the values method, which gets assigned to this variable. But here's the fascinating part about these 2 results. They are actually views. This variable doesn't just hold a static snapshot of the values from when you ran the code. Instead, it acts as a live pointer to the keys and values. They aren't physically stored anywhere else. We can prove this by printing the state before and after. First, we print the initial keys and values, the current vehicles and their status. Now, let's add a new truck, Truck 4. It's working hard and is already out delivering. Let's run the print command again to see what happens. As you can see, the initial values are right here. Trucks 1, 2, and 3. Delivering is first, then idle, and maintenance is third. But then we add the new truck and check the active vehicles. Remember, these were assigned to the variable before we added the line. Yet, truck 4 appears in the output anyway. Even though it was added after the assignment, the same goes for the values. It appeared instantly without any reassignment. This demonstrates that you are essentially looking into a mirror. If you put a hat on your head and look in the mirror shows that hat immediately. That is exactly how Python dictionary views function. These methods return live views, which are stored in your variables. Just like a mirror, they always reflect the live reality of the original dictionary. Whether you add a new entry or change an old one, those updates show up instantly in the view. This is a critical concept to master. You will encounter this throughout your Python career. Hey Python fans, want to master the difference between pop and Popitem? Stick around because we are diving in now. Let's look at this dictionary of user sessions. We have user 1, user 2, and user 3. Notice how user 2 has expired. We need to remove that specific user from the list. How do we do it? We call the pop method and provide the key user 2. Since user 2 is our target key, our variable will now store the removed value, which is expired. That's the key and its value handled. We extract that specific data and save it to a variable. Now, let's print the result. Running the code shows we've successfully removed expired. But Popitem behaves differently. Notice it takes no parameters. Unlike the pop method, Popitem always removes the very last item. It follows the last in, first out rule, known as LIFO. Here's our removed item. In this case, it returns both the key and the value. Watch this. It removed the last entry in the dictionary, which was the letter C and the number 3. Now, our dictionary only contains A and B. So Popitem clears the last entry automatically, while pop targets a specific key that you choose. Popitem gives you the pair because you aren't picking the key, whereas with the pop method, you already know exactly what you're removing. Both of these are incredibly useful. Use Popitem to build a stack using the LIFO principle. Use pop to clean up specific data, like our expired user. It's the perfect way to manage your system. If you enjoyed this, please like, subscribe, and comment. Tell me which Python feature puzzles you, and I will break it down in the next video. Do you really understand how shallow copies work in Python? If you're not 100% sure, you need to watch this. Otherwise, you'll risk making some massive coding blunders. We'll start with a variable named original. It is holding a dictionary. The curly braces are our first giveaway here. Notice the items are separated by colons. User is the label and Sarah is the name. Sarah's skills are Python and SQL, and this right here is a list. Now let's create a new variable called copied. We are going to perform a shallow copy. A shallow copy only duplicates the immutable types. But what is immutable? Simply put, things that cannot be changed. In Python, a string is fixed and cannot be altered, but a list, that's different. A shallow copy won't create a fresh version of it. Let's see that pitfall in action right now. In the copied version, we'll change the name to David. What do you think will happen? Next, we'll update the skills and add Docker to the list. We are appending Docker straight to the end. Ready for the results? Take a look. Think about this carefully. Shallow copy versus deep copy. When we run this code, look at our first printout. In the original variable, the user Sarah stayed the same. But notice Docker was added to Sarah as well, even though we only added it to the copied variable. The name David was successfully updated, and the skill Docker was appended there too. This is a critical concept to master in Python. The copy method creates a shallow duplicate. It only scratches the surface of your data. For strings, which are immutable, it creates a new memory pointer. It pointed away from Sarah to David in a new memory slot. But for the list, it's still pointing to the same location. Both variables are actually sharing the exact same list, and that is exactly why Docker appeared. Items that cannot change get a new reference, but mutable objects stay connected. Just remember how this works. For mutable types, the parts that can change share one address, while other data is physically copied somewhere else. That's why the names differ, but the skills, well, they both point to the exact same spot in memory. Do you know the difference between the update method and the pipe operator? If not, you're missing a vital piece of the Python puzzle. Let's master this right now. I'm on a mission to teach 1 billion people Python. That is my goal. Take a look at this dictionary, employee name. Here's the label, and here is the value. Label and value. The name is Maya. The department is sales. Maya currently works from the office. She isn't remote yet. She's in sales for now. But today, Maya is moving to the engineering team. And she's finally going remote. So, we need to update her profile. Let's change her status. Who wouldn't want that? First, the update method. It takes in a dictionary. What's happening here? Look at this dictionary structure. We set department to engineering and remote to true. Notice this. The update method changes the original variable directly. It modifies the existing object right where it lives. It overwrites the old data with her new department and remote status. When we run this, you'll see the name is the same, but she is now in engineering and working remotely. Lucky Maya, just like me. Now, the pipe operator is different. We have the exact same structure, the same starting dictionary, but notice we are creating a new variable, updated employee. On the left of the equals sign, we use that pipe symbol. We put the original variable on the left and the new data dictionary on the right. It's the same logic, changing the department to engineering. But watch what happens when we run this. The original employee has not changed. The original stays the same, but updated employee is a brand new dictionary with the changes applied. Maya is engineering and remote only in the new version. So here's the golden rule. Update modifies the existing variable. The pipe operator creates a fresh dictionary and stores it in a new variable. That is the core difference. Use update to change an object without creating a new one. Use the pipe if you want to compare. Now it's easy to see the transformation. She was in sales. Now she's heading to engineering. She was in the office, but now she has the freedom to work from home. If you found this helpful, like, comment, and subscribe. Help me reach my goal of teaching 1 billion people.